Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 12.2, Problem 7. This is Section 12.2, Problem number 7. It says f of x is x squared plus 3x minus 5 over 9x squared minus 4x plus 6. Part A, what is f prime of x, or in other words, what is the derivative? And part B, what is f prime of x when x is 2? So for part A, to take the derivative, the function we're taking the derivative of is a quotient. It has a numerator and a denominator, so we're going to use the quotient rule. So we have x squared plus 3x minus 5 over 9x squared minus 4x plus 6. So the top part of the function is the u, and the bottom part of the function is the v, and we take the derivative by using the quotient rule, which is f prime of x equals vu prime minus uv prime over v squared. So let's fill this in. So we start with v as the first part of our quotient rule, just the denominator with no prime, no derivative. So v is 9x squared minus 4x plus 6. Then times u prime. So u is the numerator of our function, and u prime would be the derivative of the numerator. So the first piece of the numerator is x squared. Its derivative is 2x to the first. Again, the exponent of 2 comes down times the number in front. There's no number written in front of the x squared. You can assume it's 1x squared. So 2 times 1 is 2. X to 1 less power. The second power drops down to a first power, so I have 2x. The next piece of my numerator is 3x. The derivative of 3x is just simply 3. Again, when you have an x to the first power, its derivative is whatever number is in front of the x. The last piece of the numerator that we have to take the derivative of is the negative 5. Since it has no x, its derivative is 0. So I'm really done with the u prime at 2x plus 3. Then I have minus in my quotient rule. Minus. Then u, no prime, just u, just the numerator of the function, no derivative. So it's x squared plus 3x minus 5. X squared plus 3x minus 5. And finally, I have v prime. And again, v is the denominator. Right? So v prime is the derivative of the denominator. The first piece of the denominator, or the v, is 9x squared. Its derivative is 18x to the first. And again, that comes from the exponent of 2 coming down times the number in front, the 9. 2 times 9 is 18. Then x to 1 less power. The second power drops down to a first power. The next piece of the denominator, or the v, is minus 4x. Its derivative would be minus 4. And again, whenever you have an x to the first power, the derivative is whatever number is in front of that x. So in this case, minus 4. The plus 6 on the end has no x with it. So its derivative is just simply 0. So I don't even have to write that. And that takes care of the top portion of our quotient rule, the vu prime minus uv prime. And I put v squared in the denominator. No prime, just v squared. So v is 9x squared minus 4x plus 6. And we're going to raise that to the second power. And that's the answer for part A. That is f prime of x. And it can be simplified. But what we'd really want to do with this is evaluate it for different values of x, which we can do now. So even though you can clean it up, you can cancel off a few things in the numerator and combine them. The amount of work involved doesn't really justify just starting to plug in values for x. So right now, the part B says put in a 2 for x in the answer for f prime of x. We can do that right now. So f prime of 2 for part B equals, so in this parenthesis here, I'm going to have 9 times 2 squared. So 2 squared is 4 times the 9 in front is 36. Then minus 4 times x becomes minus 4 times 2, which will be 8, minus 8. And there's a plus 6 on the end. The next part of the answer, 2x plus 3. So if I put in a 2 for x, 2x becomes 2 times 2, which is 4, plus 3 more. I can just make that a 7 right now. Then I have minus. And now, in this parenthesis, everywhere I have an x, I'm going to put in a 2. X squared becomes 2 squared. 2 times 2, so that's 4. 3x, or 3 times x, becomes 3 times 2. When I put in a 2 for x, 3 times 2 will give me a 6. And then there's a minus 5 at the end of that. I'll close those parentheses. One more set of parentheses here. 18 times x minus 4 becomes 18 times 2 minus 4. 18 times 2 is 36. And I might as well do right now 36 minus 4 is 32. And in the denominator, I have basically the same as I have in the first set of parentheses in my answer, except there's a second power. So the 9x squared becomes 9 times 2 squared, or 9 times 4. So the first piece will be a 36. Then minus 4 times x becomes minus 4 times 2, which is minus 8. And I have a plus 6 at the end. But I have to remember, after I complete that computation, whatever it comes out to, I'm going to have to raise it to the second power. So that gets the process started. Let me simplify it down a little bit more. F prime of 2 equals. So now, I have a set of parentheses here in my answer that has 36 minus 8 plus 6 in it. So if I do that work, let me do the positives first. 36 and 6 is 42. 42 minus 8 is 34. And it's going to be 34 times 7 minus 4 plus 6 is 10, then 10 minus 5. 10 minus 5 is positive 5 times 32. And if this parenthesis here came out to 34 before, when I do the same work, it's going to be 34 again. I mean, we can do it again. 36 minus 8 would be 28, and then 28 and 28 and 6 would be 34. But don't forget that 34 will be raised to the second power. So now I can start simplifying a little bit more. 34 times 7, well, 30 times 7 is 210, and it'll be another 4 times 7, 210, and another 28 is 238. Minus 5 times 32 is 160. And then the bottom 34 to the second power. So it'll be 34 times 34. That's what 34 to the second power is. So now on top, 238 minus 160. So that should be positive 78. And then underneath, 34 times 34 is 1,156. And that's even. You can reduce it if you want. So half of 78 would be 39. Half of 1156, I should just use my calculator, would be 5, let's do 1156, divide that by 2, is 578. So I have 39 over 578. And I don't think that's going to reduce any more. No, that's as far as it goes. So f prime of x when x is 2 reduces down to a final answer of 39 over 578.